Um, hmm. So the May 2020 paper, chemistry, uh, paper number one. Yes. So what is the empirical formula of butane? Right, it's a easy one. Butane means what? Butane. So it is what? C4H. Uh, they are asking the empirical formula, right? 2n plus 2, it is H10. So empirical formula means the least ratio. So the least ratio is 2 to 5, right? So answer is B. Next one, the zinc is added to copper sulfate solution. Copper is formed, right? So copper is formed means copper is here displaced because copper is at the bottom of the periodic table, reactivity series, right? So maybe you can tell it is a bit below than the zinc. So since zinc is above the reactivity series of copper, copper is being displaced, right? Which of these is the best name for this type of reaction? It is given, right? It is uh, part two, displaced per reaction, right? I have already given the answer. Which is the ionic half equation for a process that takes place during the reaction? So they are asking the ionic half reaction. So as you know, copper is being displaced means copper is reduced, right? So therefore, you can't. Uh, uh, Now remember, copper is completely being reduced, right? So, but still you can leave this for later because we have to pick the best answer. It is much better if you can have two electrons and completely reduce, but this looks suspicious, so you leave it for later. And zinc is there, zinc is getting oxidized. So the answer is D, right? So in that case, if you have suspicious answer, leave it like that, right? How many molecules are in the 44 gram carbon monoxide? So if you look at carbon monoxide, carbon is 12, oxygen is 16. So it is what? 6 plus 2, 8, 28. Carbon monoxide. How many molecules are there? 44 grams divided by 28. You can find number of moles. Number of moles multiplied by Avogadro's constant, you get the number of atoms of it, right? So roughly, it must be yeah, not 6.02. You can't be like this because when you look at the fraction, it's 1 point something. So 0.62, this can't be the answer. This is a lower value, this can't be the answer also. 1.89. Uh, for that to have, so look C, right? C is the answer, right? Why? This fraction is something like 1.302. If it is 1.203, you must get something between 6 and 10. So it is 9, right? So you don't need to simplify these things. Since you guys have a calculator, you can use. But for national students, they don't get the calculator, so they are they are practicing all the time these kind of techniques. So I am also used to that actually, right? So it's good for your brain. A compound has MR84 and its composition by mass is 71.4. Carbon, right? These are bread and butter questions. So they are asking the molecular formula. First of all, you have to find the empirical formula. To find the empirical formula on the paper itself, dividing by 12, dividing by 1, dividing by 16. So yeah, so then you are getting here as 9.6. Here uh, around near 6, I guess. Oxygen is one something, right? So actually, you have to divide and see. This one you can't get away, right? It's risky. So you use your calculator and should check, right? So once you do it, you are getting the ratio as they ask the molecular formula. It is C5H8O. So with this, you are finding the empirical formula. Empirical formula multiplied by a numerical value is equal to the MR value. So if you get, so whatever the value you get as n, you must multiply the empirical formula, and that value is equal to the molecular formula. Right? That is the answer. The formula of barium chloride, which is correct for barium chloride. Uh, Barium chloride is given. What is the correct? Which is correct for barium chloride? Barium chloride exists as a molecule. No, it's an ion, right? Ionic lattice. Wrong. Barium chloride is a compound. Yes, you can consider as a compound because it is made out of more than two different types of atoms. Empirical formula is no wrong. This is the empirical formula and the molecular formula. Both are the same here. Release ratio. MR of barium chloride is 178. It can't be because here you are getting it around 70. So it goes beyond 200, right? Barium chloride is a compound. It's a very easy one. With the middle school knowledge, you can do it. Compound means something made out of combining more than two different types of atoms, right? Uh, yeah, because in the other definition you have elemental molecules. Elemental molecules are made out of same type of atoms, right? Okay. Sixth one, what is the AR of the element? Uh, our relative abundances are given here. So AR is what? You can get the molecular ion peak, right? Molecular ion peak is equal to the M mark. Molecular ion peak is what? M divided by Z. Molecular ion, yeah. So in that case, they are asking AR, but here you have to be very careful. Now here there can be an isotope also, right? So they are asking AR. So when you are looking the AR, you have two isotopes. Can you see? There are two isotopes. So one isotope is what? And the relative abundance you have to look at, right? So here when you look closely, it is what? 60. This one is 63. This one is it's 1, 2, 1, 3, 4, 5. Other one is 65. The AR means isotopic mass multiplied by relative abundance. So the relative abundances can be calculated based on the height. So you don't need to do a calculation actually. So always AR means it's an average value between these two. Right? It's an average value. So it cannot be a value more than 65 or less than 63. And again, if it is a 50-50 sample, right? The average value is what? Exactly half, 64. With the relative abundance of 50-50, it is 64. So it is sort of 50-50 sample. See why? Usually you have the here it's a higher percentage, more than 50. Usually, if you have two isotopes, the isotope with the lower mass, lower isotopic mass is more abundant. So 63 one is more abundant, right? So therefore, since 63 is more abundant, your average value is more lenient towards 63. Why? Because you have more 63 isotopes, not 65. If it is a 50-50 sample, it is right in the middle. But in this case, you have more 63s. This graph is very tall. So you must have a value between 64 and 63 because relative abundance is favoring the this value. So the answer what? Part A, answer C. So I told you without doing further calculation how to use your brain, right? I don't actually I am because if you have a trained mind, you don't need to do all the calculation. Your logical thing can get the answers, right? So I want you to train your mind for that. I see. Easily without doing further calculation, you can decide. Be very careful, right? You can't just pick it as 63 or 65 as an idiot. Because there are, the isotopes are also coming into play. Molecule ion peaks sometimes have a little another peak because of the isotopes. But here they are asking about AR. AR means they are asking the average. So when you are taking the average, you don't need to do a calculation. Definitely, this abundance is much greater. So therefore, you have the average value more closer to 63. If it is a 50-50 sample, it's 64. Favoring more into 63, it is 63.6. Right? No need to do any calculations. Mentally, you can get the answer. Which species could be responsible for peak m divided by z? 32.5. 32.5, they have given it to us. Now we have to be very careful. Now, sample of an element. It's an element, right? All these are elements, so right. So always, any four could be the answer. And right now it says 32.5 m divided by z value. Now remember 32.5 means where? Here, right? 62, 65. Now remember when you take the m divided by z values, right? Uh, if it is sulfur, it is what? 32. 63 m divided by z value means 63 divided by 2. Uh, Here 65 divided by 2, 32.5. Here It must be RC, but be careful now. There's D1 nodes. Let's see. Right? You have 3. 3 times 3. 3 times 2. Ah, no, this is the perfect answer. So remember, we are doing science. Keep that in mind. If you read the paper, they have instructed us to find the most suitable answer. Most suitable answer. There's nothing called correct answer or wrong answer. Out of 4, most suitable answer. So always you have to pay attention to other answers also. Based on the answers, you should know how to get the answer. Otherwise, I could have just go through a share a marking scheme here and discuss with you. So you could have done it of your own, but I want to be in your seat. I want you to learn how to think in a paper. Otherwise, any person can, we can share a marking scheme and look at it. No, I want to be in your seat, right? That's not the way to do it. Now, this is how you do as a student. Right now, I am with you. At this moment, I am doing the question because I want you to learn how to think. And this is how I do it. In your exam, this is how the way you do it. So you can learn something from me. At this moment, I am looking at this thing and coming up with an answer. Not prepared at all, right? So in that case, when you are doing your exam, always look at the answers, all the answers, right? Sometimes without doing any calculation, you can pick the answer. Usually, in your 4 answers, if you are watching Serious a Millionaire or any other millionaire show in America, there are something called 50-50. That is how these are designed, right? These are designed by experts. There's another panel, right? Sometimes they may even have a PhD in designing a papers. Edexcel, Pearson's and Cambridge, they have a special team. They are the ones who are coming in for trainings. Experts in making questions. They know only about only that. Not teaching, not anything else. How to make exam papers. They are experts, right? So when they are designing it, they make sure 2 of 50% of the answers are way off. So by looking at the surface level, you can pick the answer that are way off. So it is always between the remaining 50%. So if you should by looking at the answer, you should be able to decide which 2 answers are having more probability of getting selected. So between those 2 answers, you should pick carefully. So always look at all the combinations. Train your mind. Just because you feel like it is sulfur, but if you look at other answers also, see why not these? These are also giving closer values. All these are giving something around 32, right? Now, if we had a different value, for example, let's say if they had like FE, way off value, right? Then you can pick A as the answer straight away because it makes sense. But here, all these answers are something related to 32, something here. So therefore, there must be answer giving the exact value. That is the most suitable answer. The exact value is only given by copper. So next time, sometime they may give you sulfur with the same answer, but remaining answers will be way off. So in that case, most suitable answer would be sulfur 32. But based on these answers, most suitable one is this one. Keep that in mind. You are here to find the most suitable answer, right? So case by case, it's different. So train your mind. Train your mind, right? Okay. What is the molecular formula of the compound shown? Molecular formula. Molecular formula means at what number of atoms of each element. Right? Let's start. There are some answers. Molecular formula, I told you here. How many carbons are there? 1, 2, 3, 4. It's a square. So Definitely this one is going off. So it is always between these three. Four oxygens are there. Four oxygens are there. It's kind of tricky now. Huh? All three ahead. And now it is all about hydrogens. There are two hydrogens. Be careful. Be careful. Now here it is skeletal formula. In the skeletal formula, in the carbon ring or carbon backbone, we don't mention the hydrogen. So the moment you see a skeletal formula, you convert that into a discrete formula. One here, 1, 2, 3, 4. You can't have a hydrogen. 1, 2, 3, 4. You can't have hydrogen. 1, 2, 3, 4. You can't have no, you can't. So only hydrogen is this. Check it again. No, I'm like you. I don't know what the answer is. Right? No hydrogens. There are two hydrogens here. So therefore, it looks like this. And again, check the other two. Four hydrogens never. Six hydrogen never. Definitely, this is the answer. Think fast, right? Train your brain. Okay. Uh, right. Seven is B. It doesn't take much time after you train your brain, right? Practice. Don't memorize it. It's like playing a game, right? It's like playing chess, right? A sequence of four molecules is shown. What is the molecular formula of the fifth molecule in the sequence? Sequence they're talking about. Let's see. There must be a pattern. I don't know. I may feel like two carbons, three carbons, 1, 2, 3, 4, 5 carbons, 6 carbons. 1, 2, 3, 4, 5. 4 carbons, 5 carbons. So actually, it's a homologous series. So you can remember the difference between them is CH2. Homologous series of alcohols, same family. Homologous series. O level knowledge, not even A levels, right? Alcohol. What is the molecular formula of the fifth molecule? So it means what? You can have another CH2. I don't know. Maybe let's see. If you have another CH2, 1, 2, 3, 4, 5. It should be 6 carbons. So I told you here, it is between these two, right? So if you know the uh, general formula for alcohol is CnH2n plus 1 OH, right? So if you have, yeah, if you have 5 carbons, C5, 2n plus 1 is about 11, and you are getting another hydrogen from here. Uh, okay, right? So here, you have 6 carbons, my bad. 6 carbons, so 12 plus 1 is 13, another hydrogen from OH, 14. So C6H14, oh, this is the most suitable answer. Am I so sure? No, I am not so sure. But between these two, this should be the answer, right? Uh, okay, this is the answer. What is the name of this type of sequence? I told you, remember? All our knowledge. Huh? Homologous, what is the name of this type of sequences? Functional group, homologous series, homolytic series. Homolytic series we haven't heard. Skeletal formula something else. Functional group nothing. Homologous series. So actually we call it as gradation. Gradation of physical properties. Gradation. Can you remember the terms? O level, not even A levels. Gradation of physical properties. Right? Homologous series. B. Which ion does not have electronic configuration shown? So let's see. I am looking at it. I want to find an easier way of doing it. Let's see. Not have. See the electronic configuration shown. Ah, so now you need your periodic table, right? So you find what this element is. What is this element? Period 3, third period. Why? Number of shells are equal to period. Third period. Ah, group number. Group number is 1, 2, 3, 4, 5, 8. So this is what? This is a noble gas. You are telling me, see, let's see. It's a noble gas. Right? Noble gas means third period noble gas is what? Always your Bible is a period table. Third period noble gas, it's of argon. Right. So let's look at next to argon, what do we have? Potassium plus. Uh, yeah. Question number 9, titanium 2. Okay. Does not have. Be careful, right? Even I got it wrong. Does not have. Potassium is having. Be careful, right? They are asking not having. Potassium does have. Calcium also definitely it has. Titanium. Uh, Scandium titanium. Titanium 2 plus. So it is moving 4s2. Right? So scandium titanium. What's the electronic configuration of titanium? Titanium is in the fourth shell. 4s2. 4s2. You have right 4s2, 3d 2, right? 4s2, 3d2. So therefore, even though these two electrons are removed, you still have d block, right? So that is why in titanium it is in it is a d block element. So therefore, here you have 5 shells. You have 2 electrons in the d, right? So therefore, this is the but this is a tricky one, right? Why? Sometimes you forget when you look at the periodic table. After 4s2 are gone, you may feel like this is the only thing is remaining. No, you still have D, right? 3D3, 3D2 is there. 2 electrons a D. Subshell is still there in titanium 2 plus. Scandium 3 plus. Scandium 3 plus. Scandium 3 plus. If you look at the electronic configuration, it is what? OS2, 3D1. So once all 3 electrons are gone, you are remaining only with the p shells. Yeah, therefore scandium also correct. So the answer is C. It's a good one. So I think relative to other questions, kind of not hard, but I told you, you should always look at the other answers also. If you don't look at the other answers, you may forget they are asking about the electronic configuration. Same thing happened to me. Just now I told you, right? It happens. But if you check on the other answers, even though you get it wrong, still you will realize you have done something wrong. So always look at the answers. You should be able to think fast, right? What is the electronic configuration of the nitride atom? N3 minus. So N3 minus means yeah, 8 electrons are there. It's a Nobel gas configuration. There must be 8 electrons. Why nitrogen is in fifth group? N3 minus means another 3 electrons are taken. 8 electrons. So let's see if you have where do you have uh, 8 electrons? This is the only electron configuration, right? Other answers don't have 8 electrons. Okay. Uh, okay. Which of these ions have the smallest ionic radius? Now be careful. You may feel like it is aluminium 3 plus. But remember, ionic radius depends on the shell also. If they are on the same period, same number of shells are there, then they have the more charge. It is shrinking more. It must be the ion with the smallest radius. So you feel like it is aluminium, but be very careful. So that is why you should look at other ones also. F minus. Let's start off with less least probable. Uh, Fluorine has what? Two shells. So on the paper itself, right? That is why you have a paper. You have two shells. Magnesium, look at the periodic table. Magnesium 2 plus also. After 2 electrons are gone, two shells. So between fluoride and magnesium, it is magnesium. Now let's compare magnesium with gallium. Beryllium, gallium, where do you have? Barium, gallium, thallium. Where do you have gallium? Gallium is in the third group. All still you have three. Gallium also you have three shells. Right? Gallium also you have three shells. Right? So therefore, now between magnesium and gallium, it is what? It is magnesium is a vinyl. Right? Two shells only. Now aluminium. Aluminium is next to magnesium. They are the same period. Aluminium has more charge. Therefore, aluminium is correct. So remember, always check with the other answers. Now let's say if you can't find an answer, so therefore you just have to guess and do. But I tell you always look at the other answers. Check on them also. I know it's a race against time. Always when you're finding answer, read the question, look at the answers. That way you can save up a lot of time. Right? So by look, that is why MCQs are easier. For me it is easy. I'm kind of cheating as a student. Why? It's actually cheating. Because you are given the answers. Question is there, answers are there. When you are looking at the answers, you are starting to remember what you forgot. Right? Anyone can forget, no? We can't remember everything. We forget stuff. But if you have studied enough, when you are looking at the answer, you are recalling this. Automatically brain is digging up all everything you have forgotten, right? When you're looking at the answers, automatically it comes. Your past papers. So what they do is actually they are taking the same question, they are changing it here and there, and giving it after 2 3 years. That is what they do. Same question, they are changing few answers here. So they are changing the question here and there a bit, and they give you details answer. Actually now, Edexcel and Cambridge exams are not that difficult. I'm talking relative national exams, right? So those who are doing nationals, you've got to have a very, you would have a lot of, you have to go an extra mile for it. So what we tell them is, even I did that, right? So after studying, you are done with studying and everything. You design a paper yourself by looking at the past papers. Design the paper, right? So you don't need to go up to that extent. But if you go there up to at that extent, you can definitely get a not island rank. You can even get a world rank. But for you to get up to that level, you will have to spend a lot of hours studying. I know the students who are doing international syllabuses, they don't they have the capacity, but they don't do it actually. Unlike national students, because there are a lot of burden on them, right? So they always go that extra mile. So they usually study about they have to study about 16 hours a day at minimum to get a BOA, right? So they have to work so hard on the subject, and because there's a lot of what do you say, quantity is more facts are there, questions are kind of difficult, more difficult. So and the more competition is there. So competitive exam, do exam, not a competitive exam. If you can get through certain level, you get an A. But for them, it's a competitive exam. It's not about A, B, C. It's about the rank, island rank, right? Okay. Anyways, uh, but if you can kind of be creative, right? I know you don't need to spend that part of hours for studying, but if you're targeting something like a world rank or an island rank in Edexcel, then you can do, right. So that you can get a scholarship, fee scholarship on a good university, right, or at least a half scholar. What is the percentage atom economy by mass for the production of hydrogen in the reaction shown, right? They are asking about atom economy for the production of hydrogen. So hydrogen is the usable one. They wanted to make hydrogen. So three hydrogens, molecular mass is 2 over right. So to make this to mount for the expense of what? These. So CH4 is what? Carbon is 12, hydrogen 4 16, H2O is what? 18. Right? So it is 6 over uh, 40, 14, 34, right? Into a percentage. So it looks like let's look at the answers, right? It cannot be this, right? It's a very large atom economy, right? It cannot be this. Way off. Why? See, look at the fraction. 34 over 6. Think like this. You don't need to calculate them. You guys have a calculator, right? But national students, they don't have it. But look at the fraction. It's a very little fraction, right? Multiplied by 100. So you definitely can't get this one, right? So now it is always between this. So even to get this one, 21.4 means like what? 105, right? So is this 105? It is like 6 times, it's like 106, right? So this one, it is a little bit more than 1 over 5, right? That about 105. It's like no. Now yeah, for to get an answer now it's risky now. Now for this one, don't assume you will have to use the calculator. Definitely these are the answer, right? So multiply it and see. Right, what is the value you are getting? So it looks like yeah, it's 17.6. Right? Can't be this. Can't be 8.8 to have 8.8. No, with this fraction you can't get. Definitely 17.6. So I am doing it manually. So but don't do these things at the exam, right? You have the calculator, just plug in the values and see, right? How many lone pairs of electrons are there in the outer shell of the sulfur atom in the molecule of H2S? How many electrons are there in the outer shell? Sulfur. Remember, how many lone pairs of electrons are there? Sulfur molecule is something like this. Sulfur is in group number 6. So 1, 2, 3, 4, 5, 6. How many lone pairs? These are paired. These are bonding pairs. Are there lone pairs? Here there's one lone pair. There's another one. Right? So what is the answer? 13. Answer for 13 is 2. Right? Just like water, right? So the movements are always it is about diagrams. If you can make the diagram, answer is there. Especially about the shapes of the molecule, angles of the molecule, uh, dipole movement, number of electron in the shells, right? Draw the sketch the diagram, you have the answer. Which equation represents the third ionization energy of the J? Third means A is easy one. Third means two are already been ionized. Third must happen from what? Two plus third sequence, right? You can't remove electron at once, one over other. Successive ionization energies. So it is a third successive ionization energy. So it is for J and it must be in the gaseous state. Sometimes, that is I'm telling you, look at the answers. Sometimes correct formula is there, states are wrong. It's always between gaseous ion to gaseous ions. Uh, right. A is the answer. In which sequence are the molecule in order of decreasing bond angle? Decreasing bond angle. So which angle is greater? 180. In linear molecules, 180 is the largest angle you can have. Decreasing angle means if like beryllium chloride. Beryllium chloride is 180. And also which one is having the least angles? Least angles are there. So when number of lone pairs are greater, lone pair repulsion is the greatest. So therefore bonding pair, right? Ah. Now remember, now there's no something like this also. Lone pair answer no. Here CH4 and ammonia, this one. When you compare CH4 and ammonia, tetrahedral, so therefore definitely ammonia is much bond angle is you have one lone pair. So therefore bond angle must be much closer because there's one lone pair in ammonia. So therefore From the other side, bonding angle is getting closer. Beryllium chloride. Beryllium chloride is what? Trigonal planar. Now, when you look at the molecule, you should be able to tell the shape. Trigonal planar. 120, 110, just like a fan. 180, 120, tetrahedral what? 109. So, what is the answer? 15. A. Now, these questions you should be able to do fast. Same questions are repeated. Right? By looking at the molecule, you should be able to tell the shape. Right? Okay. Which pair of ions will form the compound with the most covalent character? Most covalent. When you talk about covalent character, it is what? Uh, Polarizability. Ability and polarization power. Polarizability is for a cation. Right? When it is smaller and greater charge. Ability to attract, ability to polarize the anion. What a polarizer? Polarization strength. Right? Ability to polarize. An anion, or you call it a polarization strength. Right? Anion, ability to be polarized. For cation polarization power, anion being polarized. Being polarized means when the radius is greater and the charge is greater. Radius is greater, charge is greater, it is expanding, right? Anion. So it is easily getting polarized. Polarized means a sphericalness is becoming a sausage. When it is spherical, it is more ionic. When it is a sausage, has more covalent character. Let's look at here. Lithium and ion, sodium and bromine. Let's look at lithium. Lithium has a greater compared to sodium, has a greater polarization power, and iodine is larger in radius. Lithium is small in radius. So yeah, it's a good combination. Why iodine as the bottom, bromine is at the top. So therefore, larger radius is easy to get polarized. So between A and B it is lithium and iodine, right? Uh, Potassium, yeah, potassium in the group is at the bottom. Bottom means after lithium, hydrogen, lithium, sodium, potassium. Chlorine is also compared to iodine, does not have a larger radius. Rubidium is at the way bottom of the periodic table. So what is the answer? 16. A. Right? Smaller radius, larger radius. Anion is always a larger radius, cation is a smaller radius. And you have to think of the charge also. Now here when you look at the combinations, see, this is how your brain train your mind. You don't need to worry about charge. Why? All are having the same charge. See, they all are having the same charge. So you compare which cation is smaller, which anion is larger. How do you know? Look at the group. When you go down, radius is going up. Radius is going up. Cation over here, anion over here. Anions are halogen. Group number 7 with group number 1. And the group number 1 at the top 2 with group number 7 at the bottom. Easy peasy, right? Easily you can get full marks for MCQs. One or two may get wrong, but because of your careless mistakes. That is why I'm telling you, always look at the all the answers. Then you won't make any careless mistakes. Right? Now remember, now I am not reading you the marking scheme or anything. I don't know anything. I don't know. I will look at it. Right? I am on the same sheet. Just now I am looking at it. I'm telling you. Right? Which diagram best represent the electron density in a molecule of hydrogen chloride? Right? Ah, molecular density. Now remember, hydrogen and chlorine can't be spherical. You don't get it, and it's what between hydrogen and chlorine. It's what you have. What type of bonding? Covalent. This is ionic. Can't be. Uh, we haven't discussed anything like this. We talked about covalent bonding, means sharing electrons. So therefore, you are getting a common orbital. If you can remember the orbital geometry, it's something like this. P sp hybridized orbitals. Hybridized orbitals are getting overlap, and this is the bonding orbital. Here you have two atoms, but remember hydrogen is spherical, right? So therefore, so anyway, it's a very good one, right? So you can't expect a what, symmetrical electron distribution. Why? It cannot be symmetrical, right? Chlorine is larger, more electronegative. That is why this is wrong. If you had something like this, then this would have been the answer. But it cannot be symmetrical distributed. This is wrong. This is wrong. Equally distributed again. This is wrong. Chlorine has more electrons. Chlorine is more electronegative. But if you had an answer like this, that would have been the best answer. Because this electron cloud is common, right? Between these two atoms. But out of these answers, what is the best answer? Best answer is D. See, train your brain, right? Always, even when you're looking at a mass marking scheme also, even you're getting answers wrong also, always argue why this answer is wrong. This could have been the answer. Think logically, right? So you cannot get the answer just directly from the books, right? D is the answer. Okay, now we have discussed all the MCQs today, and I will end the class for today. And take care. Goodbye. See you next week. Bye bye.